UI in Unity can be a struggle. If you use the standard UI system and you want to change the look, you have to go through your entire hierarchy and tediously set each individual color, font, sprite, etc., which can really suck the fun out of your development, especially if your whole game's UI is already established. So, in this video, we'll make a system where you can create a UI skin using scriptable object architecture and apply it to your whole project with a single button press. Let's begin. Start by creating a script, which I'll call ScriptableTag, inherit from ScriptableObject, and add a Create Asset menu attribute so we can create these from the inspector. And that's actually it for this script. Now create a mono-behavior script, which I'll call TagContainer, add a public field for an array of scriptable tags, and add a Boolean function called contains_any that accepts another array of scriptable tags. I could use loops here, but instead I'll just use the intersect method from the system.link namespace and return true if its count is non-zero. In case you've never taken a foundational math class, an intersect is a mathematical function performed on two sets where the result is the overlap between those sets. So in this case, the result is a collection of scriptable tags that exist in both arrays. Next, create another scriptable object script called TagProcessor. Make it abstract, add a public field again for an array of scriptable tags, and create an abstract void method called process, which accepts an array of scriptable tags, a reference to a list of objects, and a reference to a list of actions. These last two parameters will help to give us undo functionality, since we don't want to break dozens of objects within our scene with no way to undo it. I'll also add some constant fields, which will help when adding attributes to future implementations. The idea with this script is that we can override this method in multiple places to handle the separation of concerns when modifying different aspects of our UI elements. So with that, let's add our first tag processor. Create another script called colorProcessor, inheriting from TagProcessor. Override the process method, and for the implementation, we'll iterate through each TagContainer component and filter the results with an if statement using the contains_any method. When we imagine modifying the color of a UI component, we could be modifying a number of things, including an image, a TextMesh Pro component, or any number of things specific to your project. And this is where we'll add the logic to test for those cases and apply the settings we want. With that in mind, try getting an image component from the tag container. Then, if it exists, add the component to the undo list. Then for the action list, we can use a lambda statement to add an action which modifies the image's color using a class-level color field. We can apply the same pattern with the TextMesh Pro UGUI type, so this will work for both image and text components. I'll also add a continue here as a minor optimization, since an image and a text component can't exist on the same game object, but be sure to account for your own use case. Before adding the final script, let's add a few more tag processors. The first will be a font processor, which accepts a TextMesh Pro font asset and uses the same pattern to modify the font on the TextMesh Pro UGUI component. Next will be a sprite processor, which will modify the sprite property of image components. And the last and most complex will be a selectable processor, which has 5 colors, being the normal, highlighted, pressed, selected, and disabled colors you'd find on a button, for example. Setting the colors here works a little differently, but the pattern is the same. I won't be demoing this in this video, but it could be useful if you want to do something like invert the disabled and normal colors. Now, create the final required script for the setup, which I'll call TagPass. Again, add a Create Asset menu attribute, then add a field for an array of tag processors and a void apply method. In this method, find all tag containers in the scene, then create an action list and an object list. Now iterate through each tag processor, calling its process method. Afterward, we can use the undo.recordObjects to record the state of all of our components before modifying them. Then call each action in the actions list, and for each object in the undo list, use editorUtility.setDirty so we can save the changes to our scene. We should also block off these bits with preprocessor directives, otherwise this code won't compile when we try to build. At the end, I'll add a debug just to show how many components were modified, and above the class, add a custom editor block with a button to call this method. That's it for the scripting, so now let's handle the editor portion and add some tags. It's important to have an idea of what kind of tags you want to create, otherwise you could end up with a mess of redundant tags that could slow your development. For UI skinning, I'd recommend describing each individual UI element, like a button, label, text hint, panel, overlay, slider head, slider body, slider fill, checkbox, checkmark, drop-down arrow, and more. Alternatively, you could also create tags to describe specific colors or sprites. Whatever works for you, just try to keep it consistent. Once you're finished with that, let's start adding tag processors. When thinking about what to call these, we need to have an idea of what kind of color scheme we want to have in place. I recommend doing some reading about UI design and color schemes, and using an online color scheme generator. I like this article about dark themes, and I'll link these in the description. I'll create some color processors like background color, overlay color, primary color, accent color, text color, hint color, and so on. Then I'll create a single font processor so that all of our fonts match, and 2 sprite processors for check marks and drop-down arrows. Next, we'll go through our scene and add tag container components to each game object that we want to skin. I know I said we'd avoid this earlier in the video, but the advantage is that we only have to do this once as a way for our TagPass to find the objects, and we don't have to think right now about the settings we want to apply to them. You'll probably find the copy-paste component as new functions useful here to speed this up. Finally, create a TagPass and reference each processor that you want to use on a single pass. If you're worried about a process with multiple tags being overridden, remember that their order in this array is the order in which the processors will be applied. And that's pretty much it. At this point, you'll just have to experiment and work on your own tagging architecture and setup. If you have this issue where skin parts are applying to things that they weren't supposed to, it's because you forgot to check if some of the tag containers contained their tags, like me. That's why it's important to add undo support and not code at 1:30 in the morning. If you caught that, great job. If not, go back and add these lines of code. On the other hand, if bits aren't applying to things that they were supposed to, you might have forgotten to add tags to your processors like I did with the fonts. Theoretically, you could add tag processors to automate just about everything in the editor. You could add or remove components, add animations, modify text properties, change materials, or whatever else you can find a use for. This is a generic solution to modify a large number of existing objects in your scene, so keep this in mind when you find yourself scrolling through your hierarchy to do the same thing to a bunch of objects. It is possible to run this on multiple scenes in a standalone build. If, for example, you want the user to be able to swap between dark and light themes. To do this, you'd have to change the find objects of type in your TagPass to instead reference all of the scenes in your build, then iterate through their root game objects. Let me know if you'd like to see this in a future video. I'd also like to mention that I've created a GitHub repository for all of my tutorial code, so check that out if you want to compare code. Anyways, I hope you learned something or found this useful. I'm still new to tutorials, and your feedback would do a lot to help me improve. So leave a comment if you have any questions, suggestions, or improvements for me, and have a wonderful day.